Bismillahirrahmanirrahim. Dear students, today we will start chapter number 9. From chapter number 9 we will start trigonometry. Trigonometry is an important branch of mathematics. For study of calculus, it is essential to have a sound knowledge of trigonometry. So for trigonometry, our first topic is units of measures of angles. So very first is concept of an angle. Yes girls, we have two formations. First one, when it is anti-clockwise. And the second one is when we have a clockwise direction. This one is clockwise and the first one is anti-clockwise. We need anti-clockwise formation. Now, an angle is said to be positive or negative if the rotation is anti-clockwise or clockwise. Angles are usually denoted by Greek letters such as alpha, beta, gamma, theta, etc. So if formation is anti-clockwise, it will be positive, and when the rotation is clockwise, then it will be negative. There are two commonly used measurements for angles. One is degrees and the other one is radian. Now the one with degree, minute and second, this is called sexagesimal system. Now here, yes students, if we have a ray and using anti-clockwise formation, draw a complete rotation. Look that this complete rotation shows that it completes one circle. So it shows that there are 360-degree angles in a one circle. So, if there are 360-degree angles, so here it is one rotation. As we use anti-clockwise, so if you look at this circle, there are 60 minutes in one rotation. Second one is when we have half. So here we have in this one half rotation means (30 minutes), and similarly if we have one-fourth rotation, it will be 15 minutes. One is complete rotation, one rotation. In the anti-clockwise, there are 360-degree angles. In half rotation, where there are 30 minutes, this one is 180 degree, because in one complete rotation there will be 360 degree angles. So what it shows, in one rotation there are 60 minutes and there will be 360 degree angles. In half rotation there will be 30 minutes and there will be 180 degree angles. And in 1/4 rotation, when 15 minutes, there will be 90 degree angles. Duster. Now, one rotation, 360 degree angles, 1 degree, 60 minutes. It implies that 1 minute will be equal to 1 by 60 degree. Similarly, 1 minute is equal to 60 seconds. This implies that 1 second is equal to 1 over 60 minutes. And 1 degree is equal to 60 into 60 seconds. This implies that 1 second is equal to 1 over 3600 degree. So students, we will use these three conditions to solve our question. Here, conversion of degrees, this sexagesimal to a decimal form. For example, here we have one example. Follow this example. I have written all the terms, all the values. Question is, convert 16 degree 30 minutes into decimal form. We know that this, first of all, we convert it into, this one becomes 16 plus 16 degree 30 minutes. So in order to convert it into decimal, we need to convert these minutes into degrees. Look at this, as 1 degree is equal to 60 minutes and 1 minute is equal to 1 by 60. So 16 remains as it is, and this 30 becomes 30 into 1 minute, 16 degree plus, instead of minute, we will use its value, which is 1 over 60 degree. So whole of this value becomes 16 plus, and when we cancel, it becomes 1 by 2 degree. So it becomes 16.5 degree. This is the method how we convert any question from sexagesimal to decimal form. One more example. Another example is, if we have 18 degree 6 minutes and 21 seconds. How we convert it into degree, into decimal degree form. First value is 18 degree plus 6 minutes and 21 into 1 second. Using these three forms, degree remains as it is. 1 minute becomes 1 over 60. It becomes degree, and 21 into 1 over 3600, it becomes degree. Now all the values are in degrees. Simplify. 18 degree plus, when you simplify 1 divided by 10 is equal to, directly write down its answer, it is 0.1 degree plus, and the third one is 0.00583 degree. So you simplify, it becomes 18.10583 degree. This is the another example in which we had minutes and seconds. So students, okay guys, one more example. 21.256 degree. Now here we will convert this decimal into minute and seconds. Let's start. First portion is 21 minutes. 21 degree plus 0.256 degree. This is 21 degree plus 256 into 1 degree. As I already explained that 1 degree is equal to 60 minutes. So we replace this degree 2.256 into 60 minutes, because 1 degree is equal to 60 minutes. Multiply, it becomes, when we remove this decimal, it becomes 15.36 minutes. Now we separate integral part and decimal part. It becomes, the second condition is minute, so here it is 15 minutes. And this decimal part, we separate it, this one. Now further we will simplify this one, we convert it into seconds. 21 degree plus 15 minutes plus 0.36 into 1 minute. And we know that there are 60 seconds in 1 minute. 60 seconds, because 1 minute is equal to 60 seconds. Now again multiply 21 degree plus 15 minutes plus 21.06 seconds. So it becomes 21 degree 15 minutes, and when we round this, it becomes 6 only. 22 seconds. This is conversion from seconds, from decimal to degree, minute, seconds. Okay guys. So this one is the first portion in which we convert degree, minute, seconds into decimal form, and how we convert decimal form into degree, minutes and seconds. Now next one. Today we will do circular system, means that how we convert any degrees into radian. There is another system of angular measurement called the circular system. It is most useful for the study of higher mathematics. Especially in calculus, angles are measured in radians. Its definition is, radian is the measure of the angle subtended at the center of the circle by an arc whose length is equal to the radius of the circle. Here is the shape. This is center point. This is radius. Here is the radius, and this is point A, this is point B, this one is angle theta, and this one is arc AB. Consider this circle of radius r. When we construct an angle of measure AOB at the center of the circle, whose rays cut off an arc AB on the circle, whose length is equal to the radius r, where measure of angle AOB is equal to 1 radian, means that this is equal to unit circle. Now, relationship between the length of an arc, length of this arc, and radius. And what is the relationship of this arc AB with the center of the circle, or angle subtended? Here is one proof that theta is equal to L over R. Theta is the angle subtended, L is the arc AB, length of this arc AB, and R be the radius of the circle. Here is complete circle, angle theta. Here is half. This is twice. So in this form we have what it shows. First one shows that an angle of 1 radian subtends an arc AB on the circle of length is equal to 1r. An angle of half radian subtends an arc AB on the circle of length 1/2 radius. An angle of 2 radians subtends an arc AB on the circle of length 2r. Therefore, an angle of theta radian subtends an arc AB on the circle of length theta r. This is first one, 1r. This is half r. This is twice of r. So here it will be theta r. So what it shows, that length AB, this arc AB, so here it shows that AB is equal to theta r, AB is L, L is equal to theta r. It implies that this theta is equal to L over r. Here is the formula is proved. Now, when theta is equal to L over r, do remember that L is equal to 2 pi r. When theta is equal to L over R, we know that the value of L is 2 pi R. Theta, R will be cancelled. So theta is equal to 2 pi. So what it shows? That 360 degree is equal to 2 pi, or 2 pi is equal to 360 degree. Now, what about pi? Pi is equal to 180 degree, and 1 radian is equal to 180 divided by pi. Do remember this. Whenever we need to convert question from radian to degree, we will use this formation. Instead of 1 radian, we will use 180 degree divided by pi. Students, do you know that the value of pi is 3.1416? We normally use up till 2 decimal places. So 1 radian is equal to 180 divided by, instead of this pi, use its value, simplify, you will get 57.296 degree. Look that the radian is converted into degree. Another form, when we have radian, so how we convert degree into radian? Okay, further, 1 degree. So in order to convert degree into radian, we know that 1 degree is equal to pi by 180 radian, because 1 radian is equal to 180 by pi degree. So here the value of pi is it becomes, when you simplify, it becomes 0.0175 radian. So 1 degree is equal to 0.0175 radian. Do remember this one as well. So here we have now 2 formations. Whenever there is radian and you need to convert radian into degree, you will use this condition. And whenever we have 1 degree and we need to convert it into radian, we will use this second formation, that 1 degree is equal to 0.0175 radian. So we will use these 2 in order when we need to solve questions. We use these 2 conditions in these 2 examples. Here is the example. With the help of these examples, you will get clear picture. First one, 2 pi by 3 radians. So to convert it into degree, first one, this radian will be converted into 180 by pi. This is the value of 1 radian. 2 pi by 3 remains as it is. We just write down value of radian, that is 180 divided by pi. pi will be cancelled, and when we simplify, it is 60 degrees, so answer is 120 degree. Look students, that very easily we can convert just by converting radian into degree. We will get the answer. Now one more, that if we have 3 radians, no pi, it becomes, again, instead of radian, we will write down 180 divided by pi. But here we have pi as well, so still it is in the form of radian. It is 3 by pi into 180. Use the value of pi, which is 3.14. 3 divided by 3.14 into 180 degree. Simplify all of them. Answer is 171.888 degree. Here is this. Okay? Now students, let's start exercise 9.1. In 9.1, there are 17 questions. In these 17 questions, from 3 to 17, we will use method theta is equal to L over R. In question number 1, we will express the following degree values into sexagesimal, means degree, minute, second. And in question number 2, we convert the following radian measures of angles. Questions are in terms of radian, and we will convert them into degree, minutes, and seconds. Let's start with question number 1. I will solve 2 or 3 parts from this question. Rest of the parts you will solve yourself. Let's have first one. First one is 30 degree. 30 degree, we need to convert it into radian. 30 degree. As I just told you that 1 degree is equal to, we know that 1 degree is equal to pi by 180 radian. So simplify, it becomes, pi remains as it is, it becomes pi by 6 radian. That's all. Another example, another question, question number 10, in which there are degree and minutes, both of them are involved. So what will we do? We convert these minutes into, first into a degree, and then we will solve the whole question into radian. It is 10 degree plus 15 minutes. We know very well that 1 minute is equal to 1 by 60 degree. So we replace this 15 into 1 by 60 degree. It becomes, when we simplify, 10 degree plus 1 by 4 degree. So it becomes 10 plus 1 by 4 degree is equal to 41 by 4 degree. But we need our question into radian form, whereas our question is our answer is in terms of degree. So we need further steps. This 41 by 4 degree will be equal to 41 divided by 4 into 1 degree. We know that 1 degree is equal to pi by 180 radian. Simplify. When we simplify, it becomes 41 by 4 multiplied by 180 is equal to 720 radian. That's all. One more part, that is 12th part, in which 75 degree, 6 minutes, 30 seconds. So 75 remains as it is, plus directly I will solve, as there are 1 over 60 minutes in 1 minute is equal to 1 over 60 degree, and 30 into 1 over, as it is in terms of seconds, it becomes 3600. Simplify all of them. 75 plus 1 over 10 plus 1 divided by 1200 degree. Simplify all of them, you will get 9013 divided by 120 degree. Again, we need to convert degree into radian, so this degree becomes 9013 divided by 120 remains as it is. Instead of this degree, we will write down pi by 180 radian and multiply these two. Our answer is 9013 divided by 216 0 pi radian. This is question number 1. One more part. There was 0 degree. There was 0 degree. Another question. 0 degree. 0 multiplied by 1 degree. Instead of 1 degree, write down its value, that is pi by 180. When we multiply any type of value with 0, answer is 0. So it is 0 radian. And one more, that is 3 seconds. First of all, we convert these 3 seconds into degree and then degree into radian. It is 3 into 1 second. We know that there are 3600 into degree. Simplify, it is 1 divided by 1200 degree. Convert this degree into radian. 1 over 1200 remains as it is. Instead of this degree, it becomes pi by 180 radian. So it is pi by 216.123 radian. So here I have selected 6 questions from question number, 6 parts from question number 1. Follow these questions and solve remaining questions yourself. Now we will do question number 2. Now question number 2 of exercise 9.1. Here we need to convert the radian measures of angles into the measures of sexagesimal system, means degree, minutes, seconds. Our first part is pi by 8. This is in terms of radian. As we know that 1 radian is equal to pi by 8 remains as it is, and we convert this radian into 180 by pi, because 1 radian is equal to 180 by pi degree. Pi is cancelled. Answer is 45 by 2 degree. That's all. This is first part. One more. This is 9 pi by 5. Again, 9 by 5 pi remains as it is, and this radian will be converted into 1 radian. Radian is 180 degree divided by pi. Pi is cancelled and we multiply them. It becomes 324 degree. So this one is the method, and rest of the questions are very easy to solve. Now, from question number 3 onward, we will use rule theta is equal to L over R. I explain one part of question number 6, second part, because first one is so easy. Question number 6, find R when L is equal to 56 centimeter and theta is equal to 45 degree. When we need to solve theta is equal to L over R, one thing should be remembered, and that is that R radius and L, they are measured in terms of the same unit. For example, centimeter, meter, kilometer, whatever the unit is, they should be in same unit. Whereas the radian measure is unitless, that is simple real number. So, following this method, when we have in question number 6, when we need to find out R, we need to find out R where L is equal to 56 meter and theta is equal to 45 degree. This is not in terms of radian. So first of all, we need to convert this theta into radian. Theta is equal to 45 degree. Convert this degree into radian. As I just already told you that theta is equal to pi by 180 radian. So when you simplify using value, because we need a real number. So here, instead of pi, we will multiply it with 3.14, which is the value of pi. So it becomes 3.14 divided by 4. This is radian. So directly, in order to find out R is equal to L over theta, we just put the values. L is equal to 56, theta is equal to 3.14 divided by 4. Simplify 56 multiplied by 4 divided by 3.14. Answer is equal to 71.30. In this way, we will solve questions of L is equal to R theta. So, use this method and solve question number 3, 4, 5 and 6. Thank you students for all.